expressed, let's say, is we have 0.5, 0.5 x double prime plus 8x equals 10 cosine of pi t. And let's say we have x of 0 and x prime of 0. And let's say that both of these are set to 0. So in this type of formulation, this is 0.5 here. Second order, right? So here we have the values. We could write this as 0.5 x double prime 0 x prime 8x equals 10 cosine of pi t. And if we did that, then we're saying here that the value of m is 0.5, the value of z is 0, and the value of k is 8. Also here, the natural frequency, we're saying that omega 0 would be equal to pi. But importantly, if c is 0, so in this problem, we would be saying that the damping coefficient is c equals 0. So this system is undamped, just like what we were discussing. It was just looking at an example with actual values, right? And one thing to keep in mind is this quantity, c squared minus 4 km. Okay, so just by looking at the problem, 0.5 x double prime plus 8x equals a function of t. So let's kind of do what we were doing initially. Is this force, or so is the force with you or the force is not with you? Which one is it? The force is with you, right? So this would be force because this is a function of time there on the right-hand side. Now, by looking at the values of the parameters, in this case, c is equal to 0, so it's not subject to, there's no friction, there is no damping. The system would be force and damp, okay? But for the sake of doing some further classification, we were going to evaluate c squared minus 4 km or 4 mk, right? Look at this m x double prime plus c x prime plus kx. Think of this as, think of the characteristic equation. The characteristic equation would be a quadratic, and it would have coefficients m, c, and k, right? And if you want to find the roots of the quadratic, which you do, and you're going to end up with square root of something. The argument of that square root is square minus 4 times something else, right? Because of the formula of the quadratic, finding the roots of a quadratic. So this quantity comes directly out of that type of formula, right? And this is the quantity that we would use to classify in terms of if it were damp. It is not in this case, but if it were, this is the next thing that we would compute, because we want to know, is this, I don't know, positive, is this 0, or is this negative? And one of those values being positive, 0, or negative is what we would use to say, well, this would be critically damp, under damp, or over damp. In this case, this value is, what is it? Is it 0, positive, or negative? It's negative because z is 0, and you have minus 4 in front of two things that are positive. It's negative, right? So you wouldn't say that it's under damp. But if c were non-zero, then, and you compute c squared minus 4 mk, then that's what you would use to classify.